In a previous video, I explained how to obtain the inverse of a matrix by finding the reduced row echelon form of the augmented matrix. In this video, I will be speaking a little more about this reduced row echelon form of a matrix. This is an example. The augmented matrix that we have before, we obtain here the reduced row echelon form. How can I recognize that we have the reduced row echelon form of a matrix? First of all rows consisting in only zero are at the bottom of the matrix. In this case, there is no row consisting in only zeros. But if there were one of them, then this row will be at the bottom. But this is the first condition. The second condition is that the first non-zero entry in a non-zero row, this is called the leading entry, is a number 1. So look at that. If you see the fourth row, the first entry that is not zero is this one. The first, in the third row, the first entry that is not zero is this one. Always is a 1, the leading entry. So the first entry that is not zero. And if it is not in the first row, is located strictly to the right of the leading entry of the row above. For example, this one that is in the fourth row, this leading entry is strictly to the right of the entries above. This number 1 is to the right of the entry of the row above. And again, this 1 is to the right of the entry of the row above. Whatever one that is a leading entry is to the right of a 1 that is a leading entry of the row above. And this is the second condition. And the third condition is each column containing a leading entry has 0 in its other entries. For example, this one, this is a leading entry, but in this column, the other entries are 0. This again, this is a leading entry, but the other entry in that column are 0. And that happened on the entries, on the columns that have a leading entry. So this is an example of a reduced row echelon form. Let's see other examples. For example, this, look at that. All the rows that have only 0 entries are at the bottom. And if you notice, the first entry of each row, containing only zeros, are 1s. Look at that. This is a 1, this is a 1. And you will also notice the third condition, that in each column where you find a leading entry, the other numbers, the other entries are 0. You notice that this 1 is to the right of the 1 that is in the row above. Another example is this. The identity is actually a reduced row echelon form of a matrix. Oh, this one, if they have a row of 0, but this is at the bottom. And look at the leading entries, they are 1. To find a reduced row echelon form is very important, not only for finding the identity of a matrix, but you are going to see that for solving equations will be very important. Here is another example. You see, the only row that consists of only 0 is at the bottom, and the leading entries are 1, and also any entry, any column that have a leading entry, all the other elements are 0. So all of these are examples of reduced row echelon form of matrices. In R, we need to install the package Pragma for getting the reduced row echelon form of a matrix. So we can obtain, there is software for obtaining a reduced row echelon form of a matrix, and one of them is R. But if you use R, you will need to install the package Pragma. In another video, I will be explaining how to get Pragma for your R, and also how to compute the reduced row echelon form of a matrix using R. The command RREF is the one that you are going to use for getting the reduced row echelon form of a matrix when you are using R. And obviously there will be also a command for getting the inverse if you are using Pragma, and the command is this INV. In another video I will be explaining this last part. I will be stopping here. I hope you have found this video useful. Thank you.